Okay, so let's try question 9, which is a calculus question. It involves stationary points, it involves the second derivative, it involves integrating for part 3, so we can find the actual equation of the curve. I guess it's important with these kind of questions which have a little bit of everything to know exactly which method you're using for which part of it, so they don't get too confused. Okay, so first of all, we don't know what the function is, but we do know that the first derivative, or the gradient function, is this lovely looking function here. 3x to the power of a half, another 3x, but this time to the power of negative a half, and minus 10. And for part 1, they want you to use this thing, the substitution, which we'll come back to in a moment, and to find the values of x where this curve has stationary points. So you've already been given the derivative, so you don't have to do any more differentiating. All you have to do is set that equal to 0 and then solve it to find the values of x, right? So I'm going to do this 2 ways. I'm going to do the first way without using that substitution, and the second way with it. So I can show you, I guess, a couple of methods for it. And then you can decide if this comes up again, which one you choose. So if I don't use the substitution that they've suggested, I'm going to leave it how it is. But you know what I've said to you before is that when I'm solving equations, I don't like to use negative powers or fractional powers. I like to write them how they are. So if I write them how they are, that x to the power of a half becomes the square root of x. And this x to the power of a negative half, the negative means the power of that whole sort of thing is on the bottom of the fraction, and the half means it's a square root. So that actually is the same as 3 over the square root of x. And then we've got the minus 10 still there, and we're going to make this equal to 0 because it's already the gradient function, and we want to find out when the gradient is 0. And those would be our stationary points. Okay, so what can we do from here? Well, we can start to solve it, and we like to solve our equations by having everything on the same level. At the moment, we've got this fraction here, and it's over root x. So how could we make this all on the same level? Well, we can multiply everything in here by root x. Okay, so if we multiply everything by root x, I get 3 root x root x. If I multiply this by root x, it's going to cancel out this one. I'm going to write it out in full just so you can see what I'm doing. So I multiply this by root x, and I multiply this term by root x here, and then that's root x times 0 will still be 0. Okay, so this is a technique you can do. So I guess it's kind of like multiplying both sides by 2, or dividing both sides by 3, those kind of techniques. You can do the same thing with the values for x as well. Okay, so why was that kind of helpful? Well, now I can go through and I can tidy things up. So a root x times a root x is the same as x. So that becomes 3x. Here, I've got root x over x, so they would cancel out and divide through, so it would become 3. I still have this root x here, and then this all equals 0. So it's still not ideal because I still don't have something that looks like a quadratic. In fact, what I have instead is still got this root of x, right, which is not too helpful. So I'm going to find a way to make this. So I'm going to square things so that I can get rid of that root x, but I'm going to actually move things around first. So I'm going to make this 10 root x. I'm going to add that to both sides. And the reason I've done that is for no reason apart from that it's easier if I square 2 terms, that's like a quadratic expansion, rather than squaring all 3 terms. So it just makes the algebra a little bit easier. You'll still get the same answer. If you decide to square all of that, you just have to do you have to do a lot more multiplication, I suppose, with your expansion. So yeah, okay, so that's cool. So let's just move this up so I've got a bit of space to show you what happens next. Sometimes it moves it all together and sometimes it doesn't. It's a bit confusing. I'm not entirely sure how this app on my iPad works, but anyway. Okay, so just moved it up. I shouldn't write so big. That's part of my problem. Okay, I'm actually also going to, before I square things, I'm actually going to just factorize that just to make it a little bit easier. Okay, so if I square both sides like this, Okay, what I end up with is 9 x plus 1 squared, and I end up over on the side with 10 times 10, which is 100, and root x times root x, which is x, like that. Cool. And then from this point onwards, you can see we've got like the basic elements that we need for a quadratic. We just need to expand out this bracket here, and then group up like terms, and then solve the whole thing. So, oh my gosh, no idea how some of these things move and others don't. Okay, move that out of the way. Okay, cool, so let's do that. So if I expand this whole bracket out, I'm going to leave the 9 out the front for now. If I expand that out, I get x squared plus 2x plus 1, and over here I get still 100x. Cool. Okay, so that's 9x squared plus 18x plus 9. We're going to take away that 100x there, and so I end up with 9x squared. What do I get? Minus 82 plus 9, so minus 82x plus 9 equals 0. So when I factorise that, I'm going to get 9x and x as my two brackets. Sorry, they're not side by side. I ran out of space. And I'm going to use -3 and -3, or -9 and -1, to get this 82. And because I'm getting 82, it needs to be -9 and -1. So it's going to be a -1 there and a -9 there. When you expand that out, you would get this whole expression here. Cool. So that means that my two solutions are x equals 9 or x equals 1/9, which is the answer to that question. Okay, so I just had a look at the schedule, like I do after I solve these questions, and just to be pointed out, in the schedule they've made a typo, so they've got the last line as still square root of x equals 9 or 1/9, but it should just say x equals 9 or 1/9. Okay, so I want to show you that method first, so that you can see that, I mean, it is possible to do it without substitution, and you can still get the answer, but you might see that actually doing a substitution makes it a little bit faster, a little bit easier. Okay, so how does it work? So we still go back to the derivative that they've given us, which is this baby here. And all we're going to do now is we're going to use the substitution they've given us. So u is the same as x to the power of a half. So I'm going to go back to this expression here, and whenever I see x to the power of a half, I'm going to replace it with a u. That does mean that our function actually now is actually in terms of u. That kind of makes a funny acronym. But anyway, right, so if I replace it with a u now, that's going to be the same as 3u. So all I've done here is taken x to the power of a half and replaced it with a u. When I try to replace it here, you've got to be careful. This is x to the power of a -1/2. So that's the same actually as x to the power of a half all to the power of a -1. Okay. So that means when I replace it here, I get 3u to the power of -1, like that. And then I get my -10. So we're still trying to find when the gradient function equals 0. So we still set this equal to 0. And there's some similar things here in terms of the structure of our equation. And the same advice from me is actually, I find it, and this is my personal preference, to actually deal with negative powers by actually writing them on the denominator of the fraction like that. Cool, so actually it's really similar. So I have the same dilemma in that I have this u on the denominator of this fraction, and it's not looking like a linear equation, it's not looking like something I know how to solve. What do I do? So I'm going to do it slightly different this time, but it's still going to give us the same answer. So last time I said to you, multiply everything by u, which is cool. In essence, actually, what you're doing is creating, you're actually combining these two to make one fraction. So I'll show it to you this way, just in case it helps. I'll just move that out of the way. Okay, so if I combine this into one fraction, it's going to be 3u squared plus 3 all over u equals 10. And then, of course, I would multiply by u. So I get that. If I just move up here for a second. So then I would take 10 u away from both sides, make that equal to 0, and then factorise it. So I'd get 3u and u. And we have the same thing here, which is that this middle term is negative, so I need to have -3 and -1. And that's going to be a -1 there and a -3 there. So my two solutions are u equals 1/3 or u equals 3. So it's actually, they're pretty similar methods, even if you use substitution or not. Okay, so now I've got u equals 1/3 and 3. I need to go back and actually turn them into x values, because that's what we're after to solve this equation. Okay, so what we knew is the original substitution was that u equals x to the power of a half. Okay, so what we do is we just set each of these two values for u here equal to x equals a half to find out what the x values are. So for example, 1/3 equals x to the power of a half, which is the same as the root of x. So you'd square both sides. So x equals 1/9. I don't know why I'm doing it the other way around. And then the other solution was 3, I think. Yeah. So 3 equals x to the power of a half. So if I square both sides, then x ends up being 9. So those are my two answers. Same as what I got before, x equals 1/9 or x equals 9. Okay, on to part 2, which we love, finding out the nature of the stationary points, doing the second derivative. So we'll just pick up the same equation as before. It's already nicely in fractional powers for us, and fractional negative powers. So we don't have to write like that first before we differentiate it. And then the second derivative, we just have to be a little bit careful with all the fractions flying around. So how it works is I multiply the power by whatever the coefficient is, so that gives me 3/2, and then I take 1 off the power, so it gives me -1/2. Do the same thing here, so I'm going to get, -3/2 x to the power of -3/2. And when I differentiate -10, it's just going to be 0. Okay, so our solutions from before were that x was 1/9 or 9. So all we have to do now is put these values each into the second derivative and see if they're positive or negative. The second derivative looks kind of scary, but you can use a calculator, and the calculator will make it all easy. So those are my two x values. So actually all you have to do is decide if it's positive or negative when you substitute it in. Okay, so when I put 1/9 in here and here and whack it in the calculator, what do I get for my answer? Okay, it ends up being negative, so that makes it a maximum. And when I put in 9 into here, it ends up being positive. Okay, so that ends up making it a minimum. I should just add that I've been quite lazy with my working here. So here where I've gone from x equals 1/9 straight to saying it's negative, I should have actually substituted in to this expression here and worked out what that value was and then seen that it was negative. So it was just me taking a bit of a shortcut. When you guys do your working, you should show every step. So you should actually show substituting in 1/9 into here and actually getting the full answer for the second derivative. Okay, on to part 3, which we love this stuff, we love it. So this involves us taking the derivative and integrating it so that we get the expression for f of x. And the thing we won't know is going to be that plus c, which is why they've told us what the point is, so that we can use that to find out what the plus c is. So remember, you've got your function, and if you derive it, you get your first derivative, and if you derive it again, you get your second derivative. So if we're going down, we're deriving. And if I want to go backwards, we're integrating. Integrate. Okay. So let's integrate this. So it's got a few fractions and so forth to navigate around, but we can do this. So if I add on a power, I get 3 over 2. Okay, so now I have to divide through by 3 over 2. So remember the rule, which is that if you want to divide by a fraction, so we're going to divide by 3 over 2. That's the same as multiplying by 2/3. Okay, so in this case here, if we multiply 3 by 2/3, we'll only end up with 2, which is quite nice. Okay, next one. So we're going to add on a power. So negative a half plus 1 equals a half. And the same thing is, I'm going to divide through by a half. So dividing through by a half is the same as multiplying by 2. So 3 times 2 is 6. And then minus 10x, and then plus c. Okay, so we need to find out what that c value is. So tell us what x is, it's 4, and tell us what y is, which is negative 7. So if we set up this equation, so instead of y, we're going to put negative 7, and instead of x's, we're going to put 4. All the way along. Like so. Then all you have to do is evaluate all of this part here, take it away from negative 7, and you'll get what c is. And you should get c is 5. And then just make sure right at the end that you write out the whole function. So f of x equals 2x to the 3 over 2 plus xx to the power of half minus 10x plus 5. So that is your final answer there.